All right. Here we need to review a little bit of basics of set theory. So if we have two sets, then a function is any rule that assigns a value in the set B to each element of the set A, right? So here is an example. I don't know. So let us say that A is going to be the set of all triangles on the plane, right? So given a triangle, we can compute its area. So it assigns to every triangle its area, which is a real number. So here A, our B is the set of real numbers. Our A is the set of triangles. Okay, so it is important that our function assigns a unique value f of x to every element of A, right? So if we have a triangle, we say, I don't know, side lengths S1, S2, S3, right? So then and let us say we want to construct a function that assigns, I don't know, all the three values, S1, S2, and S3 to a triangle. Then it doesn't make sense because there are three different values. So it's not a function from the set of triangles to the set of real numbers. However, we can construct a valid function from the set of triangles to the set of triples of real numbers that assigns to every triangle the triple S1, S2, S3. If we arrange them to be consistent, we need to always say sort them in the increasing order. So S1 is less than or equal than S2, less than or equal to S3. So this is a well-defined function, right? So given a triangle, we measure its side length. Then we arrange them in the increasing order and name them S1, S2, S3. And then to every triangle, we assign the triple S1, S2, S3 as an point in the three-dimensional space. So this will be a well-defined function from the set of triangles to the three-dimensional space R3. Okay, so if additionally different points of A are mapped to different elements of B, then F is called one-to-one. So if any element of the set B is the image of some X, then F is called surjective or onto. And a function that is both one-to-one and onto is a bijective function. So another characteristic of a bijective function is that there exists the inverse function. It's the same thing. So a function is bijective if and only if there exists the inverse function. So for functions from real numbers to real numbers, we can so if this is, let's say, a function from real numbers to real numbers, so this is the graph of a function. So let's say, so this is going to be A, this is going to be B, so this is going to be C, this is going to be D. So this is a bijective function from the interval AB to the interval CD. So if this is, say, Y, this is X. All right, so whenever we have X is here, Y is here. So if Y is f of X, well, then X is going to be f inverse of Y. Okay, so this notion of a bijective function is going to be crucial to define homeomorphism, which is the central notion in topology.